Hello and welcome to Current Thinking, Eaton's new broadcast series where we look at the biggest trends affecting electrical innovation. I'm Hillary Spittle, Director of Communications for our electrical business, and today we have a topic that we know is on the minds of our viewers, especially given the real acceleration of digital solutions all across the way we manage power. When you think about all of the intelligent capabilities built into our products and solutions, how can you ensure that you're getting the most from your investment? Well, we have two experts here today who know a lot about this topic, and I will turn it over to them to introduce themselves. Dave?
Yeah, Dave Loucks. I've started in this industry quite a while ago, actually 40 years ago. The last 25 years has been with Eaton. I started as a field application engineer. I moved into product development. I ran a couple of internal startup businesses, and now I'm working for the office of our CTO, working on some internal projects, one of which I'm going to go into a little more detail later.
Great. Dan?
And I'm Dan Carnovale. I'm the manager of the facility we're in today, the Power Systems Experience Center. And I also worked in the field for quite a few years, about 30 years. The work that I did was related to power quality specifically, and I did a lot of on-site investigations of power solutions and investigations around problems. So Hillary, if we want to talk about harmonics, we could probably talk about that for about 8 hours if you want.
Oh, great. Well, we'll sign you up for another topic then. Right now we're talking about intelligent power, so that's good. And please keep in mind that we do have additional resources available for you if you're looking for more information on the topics that our experts are talking about today. You can see in your viewing portal some additional links for more information. So before we jump in, let's define an important term here, intelligent power. When we talk about that at Eaton, what we're really talking about is our framework for digital innovation. Dave, do you want to shed a little more light on that for us?
Sure. I mean, when you think of intelligent power, you might think back to, well, we've been putting microprocessors in devices for, well, honestly, as long as I've been in the industry. Devices that meter, monitor, capture data, make decisions, transmit on networks. So what are we talking about that's different about intelligent power? Well, that's a very basic level of automation, right? It's capturing the data and then making very, I'll call them simple decisions about what to do with that information. What we talk about with intelligent power takes that to a different level. It really is putting more of, like here's an expert power quality engineer who can look at this information and make decisions about it. We're talking about pushing some of that capability into the device. The reason we can do that is if you start looking at the capability of electronics now. I mean, think 2003. 2003, if you wanted to buy a gigabyte flash drive, I'm not even sure they were available, but it was about $250. You can't even buy a gigabyte flash drive. If you were to buy a flash drive today, it's about 16 cents per gigabyte. So $250 is 16 cents. That same functionality is now available in these products, so we can do so much more. The other thing that's different now is the capability of these devices is so powerful that we can embed encryption into these devices. That allows these devices to connect to the cloud, something we never could do safely before. Once you've done that, you're talking about untold increases in capability. So it's really a different kind of a model we're talking about with intelligent power.
Absolutely.
And I think that the key word when people ask me, what would intelligent power, how would you define it? I think the key word is adaptive, right? So as we think about us as people and the equipment that we put together to try to put systems together, I think it has to be adaptive and has to be able to learn and grow and move in a forward direction. I saw a neat analogy where somebody pulled out a smartphone and said, hey, look, if Alexander Graham Bell came back to life today and he looked at this thing, would he even know that it's the thing that he invented? And the answer is probably no. He wouldn't know that it's a phone, but secondly, would he even know that it's a camera and a music player and all these other things? But yet, if Westinghouse and Tesla came back and saw, the utility pole transformer, they say, well, I invented that thing. So when you look at like how we've adapted in smartphones and in some of the intelligent devices and the apps that are on those devices, as opposed to some of the power system things, now because of the availability and the cost, as Dave mentioned, of these simple devices that we can put down into the system, I think it's a real step forward in the power system world so that, 100 years from now when somebody looks back and says, what's that gray thing hanging on the pole that's still around. They might not know what it is. The other thing that comes to mind is an example from a meter that we had back in the early days of metering, the IQ analyzer. So it was a really interesting and at the time we would say it's an intelligent device, but I can't tell you the number of people that would come to me and say, look, can you help me get this data off of this device? Because, I had a problem in my plant and I bought this really expensive meter and I want to understand what happened in my plant. And I would feel bad sometimes because honestly, like there was a lot of times where people either didn't, one, program them or didn't have them connected to the system. And, because of those two kinds of, sort of simple thoughts of what you do with these devices, nowadays a lot of that is it's expected to have that data and presented in a way that most people can understand and not just the very high end, power quality experts, for example.
Right. So in your expertise then, Dan, does everything electrical now have to be intelligent?
Actually, Hillary, that's an interesting point. And, Dave and I teach a class called Power Up for young consulting engineers and also for electricians that are coming new into the business, because there's a gap, a generational gap that's coming up that we've got to fill these positions with really smart, engineers and electricians. And in that program, we talk about how do you design power systems. And one of the neat things is, like, we point out, hey, you could gold plate everything. And, you could make everything like the most expensive, the best product and everything. And 6 months down the road, you wouldn't have a job. Why? Because you've cost the customer too much money, right? The other end of it is, you could under-design it and you could say, well, I bought everything for the cheapest, the least expensive, the lowest cost. But of course, there's a happy medium. And that's what we try to promote is there's the good, better, best scenario, and trying to understand what that value associated with these intelligent devices is. There are people that don't need to have the cloud connectivity, but if you have cloud connectivity, can you use it and can you make money from it?
Yeah, and the definition of intelligence is changing. Because you think about back in the early days when we were there, the intelligence, the most sophisticated product that we could sell in those days might be, it's beneath what we would consider to be a dumb device today. So intelligence is getting pushed further and further down. And so all I would say is that you don't necessarily need to have intelligence in the device, but because of the cost structures and because of the technology, it's appearing. And there's consequences of that too.
Absolutely. So what are some examples then of solutions that apply intelligent power?
Well, one thing that comes right to mind for me is, I get a lot of visitors every year. In our experience centers, we see probably 15,000 visitors every year, and they always come in with problems. And as a power quality guy, I love that because I want to talk about, hey, tell me about your problems and let's see if we can figure it out. And so one person told me, he said, I lost $3 million last year from power problems. And I said, well, what are you doing about it? And he said, well, I'm trying to figure out what's going on. And I said, well, what are you seeing on your meters? At least let's start there. And he said, I don't have any meters, So I thought, well, I give the analogy, like that's like going to the doctor, right? And saying, hey, doc, I got a problem. And he says, we can take care of that. No worries. We'll take out your appendix. If that doesn't work, we'll put a cast on your leg. If that doesn't work, we can give you a shot. We can do brain surgery. You would never go to hopefully you don't go to a doctor and let them do that, right? But you would go and say, here's my symptoms. Here's my problem. Let's figure it out. So understanding the problems at the level where the devices are installed, down at the kind of the low level in the load end is really the important part. So 3 things come to mind of examples that we do at Eaton. One is predict pulse. So for UPSs, which are, in a lot of these data centers today, in all data centers today, are the lifeblood of the power going to the servers. And so we have to make sure they're working well. And so the UPSs that are in there, they have components just like anything. There's mean time between failure and mean time to repair and all those kind of things that people worry about. Now, if you could actually predict when a component like a capacitor inside the converter or a battery is going to fail, now you have something, right? So Predict Pulse looks and puts a lot of data on the cloud and actually is able to sort of predict and kind of look at trends towards when something might go wrong. And so inherently in that kind of a design, you're looking more to be proactive instead of reactive, and obviously that can save a lot of money. The other 2 are circuit breaker examples. One that I'm really excited about is our power defense breakers, which actually you can now get the kind of data that I was taking out of, these very expensive meters years ago at a steel mill or something like that, and actually getting it right out of the meter, out of the breaker itself. And as we know, circuit breakers feed, or, our devices would feed a lot of the loads on the system, most of the loads on the system. So as you look at that, can we now get that waveform data, the harmonic data, the information that's useful to figure out what the problems are? And the other one, the energy management circuit breaker, is the other one that's really exciting, because now if I'm a utility company and I want to do load shedding or a virtual power plant, I can take and take out 10,000 homes of one small load out of that home. I can actually take that load and use it as a variable load on my system and actually manage that load. And if I'm a customer, I can now take advantage of that benefit from a cost standpoint, or I can monitor even some things inside my home. And maybe somebody really smart, like the guys that Dave works with at the research group, can look at it and say, hey, there's health issues related to these people in this kind of a home that use this kind of electricity. And so patterns become part of that cloud computing and data.
Mm-hmm. Listening to Dan talk, it strikes me that some people might listen to this and say, that sounds really awesome, but I don't really have the people that can maintain that or really understand that technology. And, it's funny, full disclosure, we have that same issue in Eaton, because we are asked by our customers to install a lot of these devices inside of equipment. And then we've got to make sure that they're programmed properly, that they're tested properly, that, the network works. And we were running into problems where if you're going to take this and this and this and integrate them all together, they're different program loaders, different cables. They're wizard based, but different wizards. And it was just it was starting to get a little bit out of control. And so we went back to the drawing board and said, what would we need to do to be able to actually use the technology, fully use it? Because think about it. If you've bought this technology and you install it and you're only using this much, you're kind of, I hate to say wasting your money, but you've got stranded an asset. It's not being used fully. Of course, conversely, you have the situation where I've misprogrammed it. I've improperly programmed it. So anyway, we came up with this technology. Internally, we call it no touch, low touch, or NTLT. And really what it does is it removes the need to have these individual program loaders. It removes the need to have these individual wizards. It's the same tool that programs all these devices, whether it's Eaton devices or third-party devices, and it plugs into them. It automatically figures out what the settings need to be based on the specs that have been loaded into the system. It pushes those configuration values into the device. It makes a backup in the cloud. It prints a QR label, puts it on each device. And now, while it was primarily designed for the factory people, it now is in the field, and our services people who once had an issue of trying to figure out, well, what is actually being shipped into my territory? What version of firmware is in every device? What am I supposed to do? Are the latest settings in there? There's none of those questions anymore, because they can go on, they log into the cloud, they see what the settings are, and it allows, I'd say, the separation for the first time of the expert from being in front of the device. Because now I can have a person who may be geographically located who can touch the equipment, but they may not be the expert on all those different settings. They don't have to be anymore. The settings are being managed in the cloud by this expert. So that's this thing called no touch, low touch.
And part of the fear, to be honest, is, using new technologies, as you mentioned, is really kind of worried that 5 years down the road, if somebody leaves the company and not being able to reprogram it, or somebody forgot a password or whatever, that piece of it is extremely important.
Mm-hmm.
So let's talk for a minute about how this is playing out in real world applications. You've given a couple, but let's talk some more about, particularly in traditional industries, what we're seeing.
So what we're seeing, for example, in hospitals, I wouldn't call it pleasure, but I was in the hospital recently for minor surgery kind of thing. And as an engineer, I was kind of fascinated because, I'm sitting there watching the process, and I thought this is incredible, because what they would do, they give you a number, right? So then you go through and, you stop at this stop, this stop, this stop, the anesthesiologist and so forth. And, the nurses are running around with their nursing carts that are, programmable and, wireless and so forth. And they also have their iPads and whatever. And all of this is going on, and I'm watching this, and I said, this is a lot like the infrastructure, the building that's running this in the background, because if one little hiccup goes wrong, there's a problem. And in a hospital, we think of it as a safety issue. The person in the hospital bed, you have a problem, but also it's a financial risk for them too, right? There's not a lot of makeup time for that extremely important and in-demand surgeon that's going to do a certain surgery or whatever. So we think about the financial risks associated with the process. And I think that's really where we have to, think through like what's important in our daily lives in those kind of industries. And so the power system in that regard is really not altogether different. Now, what comes to mind also are like in your car. Like what happens if something happens in your car? What do? We take it to the garage and they have the whole list of all the codes. And of course, Dave, you probably have one of these right in your house. It measures the codes or whatever. But I'm going to buy one. I'll have to talk to you about. But I think, as you look at those codes, the alarms are something that I think is important to talk about from an intelligent device, because when we first start seeing these alarms, a lot of people get nervous because there's so many alarms. It can be overwhelming. And what do people do? They start to ignore them, right? So it's just another alarm. So it not only has to be intelligent, but it has to be intelligent in a way that's useful, not just giving me a whole bunch of more information, but useful information that's actually going to be proactively helping me do my job.
I mean, I'm hearing there's a theme here, this complexity. This power brings complexity. And, you mentioned the hospitals. You mentioned the operation of the hospital, but think about the construction of the hospital or any commercial real estate, a school or a data center. It's a very choreographed dance of the trades. You've got a general contractor who's working with an architect who then subs out to electrical or MEP, mechanical, electrical, plumbing contractors. There's drawings transferred between each of them. Information has to be done on a certain schedule. Because if something, like you talk about the surgeon, valuable time, I'm telling you, the tradespeople, they've got jobs backed up. So transferring information is so critical. Let's say that somebody needs a piece of information about one of these devices. Who do they go to? Where do they go? Who has the latest information? Did someone change it? Did someone say that this is something that was done earlier and I need to change it? Well, that's another thing this NTLT system does, is every single setting that is loaded into a device is then backed up in the cloud. It's made available to anyone who's credentialed in. It's available to access it. And there's no uncertainty anymore. So what it does is it reduces the risk of construction delays. It reduces warranty. It improves first-time quality. And so another example of moving a product that we thought was going to only be used in our factories and is starting to be used in our field, in the field by our engineers. And I would see one day our customers will have access to this system.
And as I look at it, the engineers that are designing it, the electricians that are on site, as you mentioned, and the building managers all play a part in that. And that's really, from an educational standpoint, that's the part that's really important, to tie it all together, make sure they all understand what's going on with that.
Mm-hmm.
So those are some great examples from traditional industries, and that's a great point, Dan, about tying it all together. How does that play out when you think about emerging industries or new sectors or applications?
Actually, it's interesting. Some of the new industries that come in here, we talk to a lot of different people, and one of the ones that comes to mind is the cannabis growers, right? So they think that, and I've seen a lot of them come in and they say, look, this is something that, we think is probably a very unique kind of system and we want to design it in a certain way and whatever. But at the end of the day, it's really just like Eaton would worry about, reliability, efficiency, and safety in our plants. It's the same thing for these growers. And so if you look at the one line, the equipment along the way is the same. The backbone from the utility all the way down, transformers and cables and everything. The load might be different at the other end, but it's not that different, really. At the end of the day, it's LED lights, it's air conditioning systems, it's maybe some, control and automation equipment and so forth. But if you look at the one line, like I said, everything seems to be relatively similar. So even in emerging industries like the cannabis growers, and even like other pharmaceuticals and maybe other manufacturing processes, a lot of them are similar, but looking to optimize reliability, efficiency, and safety. And that's the kind of things we look at as we move forward. And and we think about some of the megawatts of power that are going to these facilities and data centers. I know Dave likes to talk about the size of some of these data centers.
Yeah, I mean, when we talk about emerging applications, we think of emerging industries like, the growers, but there's a sea change, there's a shift in how individual industries are doing their business. So think about the data centers. Look at the size of these data centers. I mean, when Dan and I started in the industry, the big load on the utility grid were steel mills, 80, 90, 100 megawatts of power, enormous. There's data centers that dwarf that now. Unbelievable. Well, that has implications with respect to safety, because when you have high currents available, you have high arc flash energy. Also, there's a lot of energy consumption, and there's a lot of, you'll see it on social media talking about, well, how much greenhouse gas are these people consuming? Look at how much power they're consuming. So there's a shift in these operations to move more towards renewable energy. But renewable energy isn't as they call it. It's not dispatchable. You can't say, okay, turn on this much power because the sun might not be shining, the wind might not be blowing. So what do you do? And so there's technologies now that allow these data centers, and we'll be talking about one of the technologies that, even though they have extremely high fault currents available, they have extremely safe environments, very, very low arc flash. Likewise, we can operate on these renewable energy sources with very high reliability using technology that we've learned from our microgrid tech group. So even though it's an established industry, it's still emerging because the technology and the applications are changing.
Yeah, and as I think about the intelligent solutions, and microgrids is a great point, Dave. So as you think about how to tie all these things together, to have, just like, solar is one piece, and wind, and maybe, batteries and all these things. Mm-hmm. And all those, again, are disparate solutions until you tie them together as one solution through software, through control, through automation, and really just tying it all together to kind of optimize it. So again, optimizing the solutions through intelligent kind of people that know, but also the machines themselves, and they learn to get better.
Mm-hmm.
So we've talked about a number of great opportunities with digital technologies, but along with opportunities comes challenges too. Let's talk about the challenges for a little bit and what we see customers are facing when they're deploying solutions like this. Dave?
Yeah, we've hinted at a few of them already, but maybe one of them we haven't really gone into a lot of detail is when we start putting more intelligence into a device and relying on that device to make more decisions where that once was a human, we run the risk that if that device were compromised in some respect by a bad actor, that things that we would not want to have happen could happen. And you see it in the news all the time. Mm-hmm. So I would say that the whole aspect of cybersecurity is extremely important. We've talked about this other issue of these are complex systems now. And if you take two devices and you try to make them work together, and what if they don't? Then who's responsible? Someone has to take system responsibility, I suppose. So that would be the third one. Is they're not components. They're systems. They're groups of products into a system, and changing one product, changing the firmware on one product, might cause the rest of the system to malfunction. So, yeah, these are challenges.
And I think it brings up a good example. I know, Dave, you and I have talked about this before, but there's a data center that I was involved with that, when they initially designed the data center, they decided that it was too expensive. And they were going to figure out how to make it less expensive. So what they did was they said, well, we're not going to buy it from one group. We're going to buy it from, the UPS from this group, and the transfer switch from this group, and the switch gear from this group, and, the generators from this group. And sure enough, believe it or not, it didn't work. It's not that much of a surprise, but this is what we see, again, going back to systems. And as you think about it, why didn't it work? Because in a lab environment, that generator works fine. In a lab environment, that UPS works fine. But as you tie them together, there's system applications where things crosstalk and so forth. And believe it or not, Hillary, it was a harmonics-related problem. So I told you to get to harmonics.
How about that?
But anyway, the issue was the generators couldn't synchronize. So we had to go in and figure out a solution to try to minimize the harmonics coming from the UPSs to make sure that the generators could synchronize. And but it is a system issue. And as I look at why are people afraid to go to kind of more of a holistic approach and all this kind of stuff? As you look at actually some of the solutions, the utility industry, you remember the whole thing with the relays, right? I mean, as you look at the utility industry, you think about when there was when they started to adapt from electromechanical relays to electronic relays. That was a huge deal for the utility industry, and the reason was because they're very by a certain design. They go by a certain design for years and years and years, and are resistant to change because they know it works, and they have to, because they have to be reliable. But what was happening was there was this move towards these electronic relays, and so the first step in this process was to take the 20 or so electromechanical relays, put them on one door, and take the multifunction, or maybe a couple multifunction electronic relays, and put them on another door, and so they're backups for each other. So it wasn't a full let me jump in both feet, but it was let me try this and test it. And now everything is electronic, but honestly, to your point earlier, we're using that to make technology solutions better for ourselves and make the systems more safe and reliable. Mm-hmm. So it really is a better solution ultimately by combining all those. The other example, going back to the IQ Analyzer, I can't tell you the number of times I walked into a plant and I saw somebody with a clipboard and they're writing the data down off of the meter. And again, I'm thinking, why aren't you using technology? The data is inside that meter. Nowadays, we won't sell a meter, or we won't promote a product that doesn't at least try to present that data in a way that's useful. Because honestly, I mean, we can't expect our customers to be experts on all of this stuff. Mm-hmm. We say intelligent, but what we really mean is the products have to also be intelligent enough to know what you need as a customer.
Mm-hmm.
So I think that, the idea of system complexity is really an issue, and you've used a couple of examples of that too. I think, Dave, you alluded to another one, and that is the idea of who owns which piece of the system, mm-hmm. right? That's got to be a challenge.
Well, it is. If you have a contractor who is putting in a system that is all these different parts and pieces, and it doesn't work, in Dan's example, who do you point to? Mm-hmm. And I don't know that this is well understood. People are trying to save money. There's a lot of cost out, and there's a lot of effort in the industry to, reduce cost 5% a year or whatever. And it causes things like this to happen, which in the end causes, much more expense. But I don't know. I think that is something that needs to be brought out, and it is an important issue.
Ownership. Yeah, the lack of ownership. Yeah, that's right. I want to come back for a second to the first challenge you talked about, and that is cybersecurity and why it continues to be, or why it's a growing significant impact, right? Mm-hmm. I think, as a lot of people know, hopefully a lot of our viewers know, that Eaton has a key partnership with UL, the Safety Science Organization, to collaborate on cybersecurity standards and power management, and we have some important achievements out of that. Certainly that relationship. We're going to go into more detail in a future Current Thinking broadcast on cybersecurity, but because it's very relevant for this topic, can you talk a little bit more about the steps that we're taking mm-hmm. to build cybersecurity measures into our products?
Sure. Dan talked about that IQ Analyzer and how the person was using the clipboard and mm-hmm. It was too hard to get the information out. Well, one of the easiest ways of getting the information out is just to have it on your phone, a web page. Well, as soon as you connect a device to the cloud through the web, now you have opened up this opportunity for people to come backwards and then start trying to mess around with it. So that's what's driving the push that makes cybersecurity more and more of an issue, because we are trying to make the products easier to use. And so where do you turn? Well, there's a plethora of standards organizations, dozens of standards organizations that are working on this problem. Think of IEC, think of NIST, National Institute of Science and Technology. I mean, the U.S. government is really interested in this. The Department of Defense, Department of Homeland Security. Mm-hmm. There's worldwide organizations, UL. But there's a really interesting, I want to draw a difference between what UL is doing and maybe some of these others. These others are standards that say, this is what you need to do. Okay. Prove to me that you did it. Well, a lot of the standards are self-certified. It's perfectly acceptable for you to say, I did it. UL doesn't allow that. UL is a third-party testing lab. And what they require is that either it's an independent lab or actually UL employees, where this equipment goes into the lab, it's tested and verified against every single one of those criteria. And they'll use the same criteria as the other standards, but it's done, you aren't doing it yourself. Now, I'm not saying that companies are going to mislead. But what I'm saying is that when you have a UL 2900 label on your product, you have the assurance that that has gone through a third-party certification that, in my mind, is a higher level than a lot of the other certifications that you'll find.
Absolutely.
Yeah, and I think, to kind of chime in a little bit on that, as we get visitors here at the Experience Center, that's really top of mind for everybody. I mean, it's great. We bring up these new devices that can connect to the cloud and, the EMCB breaker and this and that. But we have to make sure that, those components are cyber secure, out of the box. And this is really important for our customers as well as us because, obviously there's risk associated with that. And as you look at, connecting physically, either through a network or whatever, or air gap kind of devices where we say, okay, there's something it's on my own little network, but it could have a way to get corrupted. We even have to look at those kind of things, and that's very important. And so I would agree that cybersecurity is really a very important piece of what we're trying to do with any intelligent device.
Absolutely. So as we think about other challenges like system complexity and lack of ownership, what are some things that Eaton's doing to help customers manage those issues too?
Well, actually, I think about back in my days in the services group, which I think is a great opportunity for anybody in their career to kind of get into a group where you're actually out in the field investigating problems. I think about what they do on a daily basis, and what they do is they tie systems together, right? So they look at it from a holistic approach, as we mentioned earlier, and kind of making sure that everything's going to work together. There was a lot of Saturday nights and weekdays, weeknights, whatever, months on end where I would go out and investigate some of these problems in the steel mill, for example. And what I'm thinking about today is, sometimes it would take me a week to get our information gathering systems, our meters and everything set up. We'd take data for a day, we'd analyze it, we'd go back another week and back and forth. And I'm thinking about like power defense breakers and how we can actually use that data right out of the devices today. I mean, it's incredible what's available to us as tools today. So I think if you don't have somebody like the investigators, the people that can tie it together, and also the people that design the systems, so the services group is really good at that, it kind of makes for a product, but maybe you can't understand how that's being used. Think about our automation group, our power systems automation group. They can take and integrate all these pieces together. It goes back to your cybersecurity questions and audits of making sure everything is going to work together. The power system engineering group, which does the arc flash studies and to make sure that things are going to be safe, and the harmonic studies, of course, are going to come back to that. But when you think about like those things, that's to me what from the services standpoint, what's going to help to make it all make sense, Hillary.
The example you gave about going out there and sort of spot checking, because the technology now allows us to embed this technology in there. I know with the medium voltage installation monitoring system, we call InsulGuard, there's always a discussion about, well, do I do continuous monitoring, do I do spot checking? And the problem with the spot checking is that depending on the humidity, depending on the temperature, depending on a lot of environmental factors, you can go at different times and get completely different readings. Whereas with a continuous, you can see it trending in a certain direction. So that's one of the big advantages, I think, when I see these intelligent devices, is not that we're going to replace a service engineer, but we're able to put lower cost, more powerful metering into these devices so that we give a richer data set to an engineer. And because we can do encryption and we can push it in the cloud, they don't have to be on the job site. So you talk about spending nights and weekends and hours, out in the rain. You didn't say that, but I mean, it's going through my mind. It was snowing. It was terrible. You can sit in your easy chair and you can do the stuff online now. So that's a big thing. So and whether it's InsulGuard, whether it's power defense, you mentioned Predict Pulse, all of these technologies and more allow us to gather this information, make the intelligent decisions, and see over that horizon, see that the thing is going to fail.
And I think another example that comes to mind also is, at our headquarters building, we had a demand charge that we found just by analyzing the demand comparison from our new meters. And it was funny because, once we looked at that, we thought, well, there's $2,400 a month we're throwing away, right? So, at that point, you think about now the instruments themselves should be pointing out, hey, I have a problem over here. That's intelligent power, right? So taking it to the next level with the devices that are capable, but having sort of the intelligence of the people that would analyze it, because there's just not enough people that can go around and figure out all the really, interesting and extra things that these devices can do.
Mm-hmm.
So thinking about devices and what's going to happen in the future, what will continue to happen, how do we see devices evolving to meet these challenges?
Well, I think of a couple of examples. I think of we talk about UPSs, and we talked about predict pulse, but then there's also this other aspect that UPS is designed to back up a power system, a mission critical power system, so that no matter what happens out in the utility, the servers continue to operate. That's a very noble goal, but reality is that the utility is extremely reliable. Dual fed sources from diverse, we're talking 4 and 5 nines of service, 99.99% and better. So that means you've made this big investment on this very expensive equipment for something that's going to happen 0.1% of the time. It's tough to get a return on investment on that. So one of the things that intelligent power has been able to do, and we said, we also said that the big loads of the old days were steel mills and now they're data centers. There's this enormous, think of it as a power supply that can pull energy from the grid and charge up a battery. It also has a battery that can then push energy normally to the servers, but there's this technology we now call energy aware UPSs that can push energy back into the utility. Now, why might you want to do that? Well, everyone knows that more and more utilities are moving to more renewables, solar, wind, the non-dispatchable loads. Well, cloud goes over, power drops off. Those utilities have very strict standards that they have to maintain a certain voltage within a very narrow band. They have to maintain frequency within a very narrow band. So the source of power just went away. What do they do? Well, one of the options is to go to their customers and say, curtail loads. Dan talked about some of that earlier, but this technology allows us to continue to feed the loads that we need to feed, but actually augment the grid by pushing power back onto the grid. Brand new technology. And we're working with partners like Microsoft. In fact, we just finished a test down in one of their huge data centers in Virginia, and the results were very promising. The other technology is, maybe talking about data centers again, you got a lot of heat in those data centers, and you got to get that moved out, so you've got these pumps and chillers and fans. Well, there is, if you lose your pumps and chillers and fans, that's almost as bad as losing your power, because these servers overheat instantly. These servers are kilowatts per unit, tens of kilowatts per rack. So you've got to have cooling. Well, we know from our work in the industry that one of the most common failures in a electrical system is a ground fault. And a lot of times ground faults occur in motors first, and there's reasons for that we won't go into. But when that happens, you would normally cause a fault which would trip everything off. That's unacceptable in the data center and mission critical applications. So people use high resistance ground systems. Been around forever. No new technology there. The new technology is, how do you find that fault when it's out there? Because the beauty of an HRG system is that the system can continue to run with the fault, but you don't know where it is. Now, there's techniques that you can use to find it, but it's very time consuming and it's very invasive. So one of the technologies that we developed using this intelligent power was inside of this motor overload relay, which is already in the system. It recognizes the unique pulsing pattern of this high resistance ground fault pulse and detects it. It will only be detected on the circuit that is actually faulted. So you could have 1,000 motors in your facility, and only the motor that has that fault on will be detected. And it detects it in 2 seconds, where it could take all day or worse. You had an example.
Well, I was going to say, I mean, when I used to go into the auto plants, they would either run high resistance grounding or ungrounded systems, Delta systems, and they had the 3 indicating lights, and it would show, good ground fault. One of the phases would be ground faulted. And I said to him, hey, the ground fault on the system. Oh, we know. Aren't you going to fix it? Oh, we can't find it. Well, when are you going to fix it? Well, later, So, and what would happen is, of course, later when they had a second ground fault on one of the other phases, they would find it because they'd trip a breaker. But the point of having an ungrounded system or a high resistance grounded system was to have that continuity. So I kind of laugh. I know you and I have talked about this in the past, but it's interesting, like 2 seconds versus, days, weeks, months. And the way that they used to find the ground faults especially on a Delta system that was not high resistance grounded, they would turn off the loads. So inherently you're saying, I don't want to turn off my loads because of any reason, and now I'm turning off my loads to find the ground faults. So that's why they didn't bother. But, talking about other technologies and other devices that we can, take advantage of new technologies, the arc quenching switchgear to me is a great example, because if you think about it, you have a relay that senses light, and within microseconds it determines that something happened inside the switchgear. An arc flash is occurring. At that point, it sends a signal to this arc quenching device, but it also is checking with some current sensors to make sure that it's a true ground fault or a true arcing fault. And once it determines that the fault's there, within 2 milliseconds to 4 milliseconds, it's actually going to activate this arc quenching device. So in the arc quenching switchgear, this arc quenching device acts like an airbag in your car. Basically, it's going to hold on and protect the gear until the upstream device trips. And the pressure wave that would build up during an event like that is like a stick of dynamite going off. So if you can detect, sense, and do something about it within 4 milliseconds, that's well below the time when that pressure wave would build up. It protects people, it protects the equipment. So an event that would normally cost over $1 million, an arc flash event's $1 million event. So an event that's at least $1 million because of the issues with people getting hurt, but also the equipment damage and downtime, you're going to protect all that for really minimal amount of money. And so I think it's a neat technology, and taking advantage of intelligent devices down at the low level inside the equipment and sensors that would have never been available in the past.
I was going to say, light sensors have been around for a number of years, and relays are available. What's unique about that technology, though, is in switchgear, as you and I know, the actual operating of a breaker can generate a flash of light that mimics an arc flash. And the technology, the intelligent power, basically there's a brain in there that's looking to see, well, did that occur inside the gear or outside the gear? Because a breaker clearing a fault that's outside the gear is perfectly normal. You don't want to operate the system, and yet it will create the exact same light, it'll create the exact same current. So being able to differentiate that from an actual internal switchgear fault, it's very cool science.
Yeah, and again, people that are seeing these videos of this device in operation and actually seeing the demos that we have here, for example, to show them how it works, to me, it's incredible. The other one that comes to mind is really related around the taking active energy control and putting it inside drives. So we know that variable frequency drives can save energy, but how much energy they save is really, across many drives now. Most people's drives are going to save about the same amount of energy today. However, running at different speeds, we know how that works. But with this patented algorithm that's built into the drive now, we have this active energy control that actually saves, on top of the normal savings, another 5, 10 or more %. And to me, that's just really smart people taking data and understanding now what it means, and making sense out of it to even save more money. So it's a programming change in an existing device that already saved a lot of money. Now you're saving more with it. That's pretty incredible to me, and I get excited about those kind of things. And I think that's something that genuinely is going to be one of those intelligent solutions that sets the example for other devices.
Yeah, a slight change in the software of a drive saves 5, 10, 15, 20, 30, whatever the percentage is depending on the load, just software. Yeah, that's pretty cool.
So great insights, and we've covered a lot. And when we think about it, let's sum it up. What are some key takeaways that you want everybody to keep in mind?
Well, yeah, we've heard a lot about the complexity and cybersecurity and single point of ownership. I guess what I would say is it's a balance. There's new products coming out all the time, but do you always need that? Or do you need, because maybe you don't have the people in place that can maintain them. In that case, maybe you do go to a lower technology. So latest and greatest, I guess, work with an engineer who has a balanced approach, which I think most engineers do. Engineering is the art of compromise. I don't know that, but also this is a very rapidly changing field. So staying current with it requires a lot of effort. You can't just simply say, well, here's my old drawings, I'm going to erase the title block, and here's the new job. there's a lot of new technology. AQD, you mentioned, C445 HRG, predict pulsars. There's new technology, so I would say that's another aspect. I'd say recognizing that these are not problems solved by a product, but they're problems solved by a solution or a system of products. And so the combination of these things affects it. And whether it's individual vendors and you ran into the situation where they don't work and you couldn't do the transfer synchronization, or whether it's a cybersecurity issue, you're integrating into a cloud provider and there's some handshaking problem. Think of it as a systems problem. And then I guess I talk about staying current on the products. Make sure your people are trained, and they have to stay up current with training, because these pieces of equipment are going to be in place for decades. And you put something in place right now, that person's going to retire. That person's going to leave that job. And who's coming in to take over? And these are important things, because especially if you let a cybersecurity flaw go undetected, you then become, there's classic cases of that where security cameras, the little IP security camera became the host vector to come in. What was the big, well, I don't want to mention any names, but we all know that there's been publicized cyber attacks that came in from, the HVAC system or something totally unrelated. So training is key also.
Yeah, and I would echo that. I think education is really the key. I mean, that's why the experience centers exist. I mean, we try to talk about actually how power systems are put together, how they work and how they don't work, and really try to bring, the next generation of people that are going to design and build and maintain these systems up to speed on what's important. And going back to Dave's point, I think technology is great. I mean, we need to use technology. I don't think we need to be afraid of it, but we also have to be cautiously optimistic. When you think about how many new gadgets and widgets and things there are out there, it's incredible. And a lot of times we see customers come to us and they'll say, look, what about this little device? It looks really cool and it looks like it would be really interesting to use. You have to also say to yourself, is that company going to be around in 5 years? Are you going to be able to use that product in 5 years? What if the software changes? Again, what if the person who knows everything about that product leaves the company? Is it going to be manageable, maintained? Power systems, as I mentioned, it wasn't kind of a joke, but there's power systems that are around 60, 70 years old. I mean, think about what a power system might look like in 10 or 20 years. Mm-hmm. And if we put intelligent devices that cripple our system, then shame on us. We have to design with the future in mind. So education becomes important, and thinking ahead of the devices that are going to be part of that is important. And I'll go back to the thing I started with the definition, which is adaptive. We can't sit still. We can't say status quo and we're not going to change from this to this, from a electromechanical relay to a multifunction relay. We have to move forward, but we can be cautious and we can do it in a thoughtful way.
Steps, yeah.
Right, absolutely. Well, Dan and Dave, thank you so much for sharing your perspectives, your experiences, your expertise with us. I think you've provided a lot of great ideas and solutions that people can use to help make sure they're getting the most out of their investment. And thanks to all of you for watching. We appreciate your interest. I hope that you'll take advantage of the additional resources that are available in the portal. You can have a look at links for more information for you. And also, we'd love to hear your feedback about current thinking about this broadcast and any ideas you may have for future broadcasts. You'll soon receive an email with a survey. It'll just take you a few minutes to complete it, and we'd love to have your input. So thanks again for watching. We'll see you soon.